Okay, ladies and gentlemen, in this video we are going to identify and utilize the equidistant chords theorem in application. We're doing my favorite example in this entire section. We're going to kind of amp it up a little bit, get us thinking a little bit outside the box for this theorem. Our equidistant chords theorem identifies that if we are in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center, okay? So two chords, CD and AB, are congruent if and only if, okay? So it's a biconditional, if they have the same distance to the center. Remember, we recognize distance from a point to a line by the perpendicular segment created by these two figures, the point and the line. And so CD and AB are congruent if and only if FE and GE are congruent or equal in length. Now, one of the most interesting examples comes up during this theorem, and I'm excited to go through it with you guys. And please make sure after this video to do the practice problem that follows it on the slides on your notes. In the diagram, the following is provided. QR and ST both have a value of 16. Okay, so both those guys have a value of 16. The value of CU is 2x, and the value of CV is 5x minus 9. Find the value of the radius of the circle. Now, I implore you, I challenge you at this point in time, pause the video and see if you just have any ideas, any recollections of how to go about this problem. Ultimately, what we want to know is we want to find the distance from the center to the circle. That's the radius, right? That's what we want to find. So I challenge you, pause, play it in your head a little bit, and see if you have any ideas. Okay, let's take a look here at this example. So this is a very interesting example because first and foremost, we are going to see here that if these chords are going to be congruent, then the distance from the center to the actual chords themselves are going to be congruent as well. So this is super interesting here. But the reality is we are left with some unknowns. Why is this so interesting and so unknown? Well, you might be saying, okay, I could just set these two guys equal to each other because they're equal in length. They are congruent segments. And you would be right. And that is a great first step. But even if you find the value of x, you're only finding the length of this red or this blue segment right here. I want the whole radius. And then the question comes into play, well, where does QR being 16 and ST being 16 come into play? Well, the good news is that told us that these two distances were equal. But since this right here is perpendicular, ultimately, it makes that these two segments and these two segments are congruent as well, making this a value of 8, this a value of 8, 8, and 8, respectively. Now we might be getting somewhere. Do you see how this can maybe be beneficial in any stretch of imagination? Well, remember what the definition of a radius is. The radius is simply from the center of the circle to any point on the circle. Don't assume that it has to be one that is already created for you in the diagram. You would agree that I could maybe create a radius from here to here. Why not? Ultimately, that's from the center to a point on the circle. And now what did I just form by creating that line? Look at my cursor. What did I just form? Well, hopefully you realize that I just formed a right triangle, and now I can utilize our good old Pythagorean theorem. But first, let's find the value of x and find the value of this red side and set 2x equal to 5x minus 9. And go ahead and find out what these values are. So negative 3x equals negative 9. So x equals a positive 3. And so then ultimately we have that the value of that red side UC, I'm going to say UC, has a value of 6. So I'm going to write over that in 6. And now at this point, hopefully you see that we do have ourselves a Pythagorean triple happening right here. But let's go ahead and just use our Pythagorean theorem for some practice anyways. So we have that 6 squared plus 8 squared equals QC squared. So we have 36 plus 64 equals QC squared, which is really 100 equals QC squared. And then, of course, QC equals 10, which basically means that our radius is going to have a value of 10.